Welcome to episode 7. In this episode we're going to be redesigning the bow to accommodate a windlass. So when I bought Seafire there was not very much up on the bow here. There was some stainless steel fender baskets here, one on each of these, so there was 4 baskets, and they were in, they were stainless but they were welded to the deck, so the weld was in real bad shape and it just had layers and layers and layers of paint put around it to try and make it look pretty. They were just horrible, so they had to come off, so I got rid of those. I refurbished them. I was going to reuse them, but I don't think I will now. I've since discovered sort of hook and rope systems that hang the fender horizontal underneath these rails, so we can have the fenders on the actual rails, not needing these little baskets for them. There was a Sampson post here, otherwise known as mooring bollard, one of those. And then there was some L-shaped, it was just like L section steel, sort of 4 inches long, 2 pieces here and here. I don't know what that was. It looked like it was something to sort of hook a rope around, but it was like an emergency measure. It wasn't a proper fitting. Somebody just cut a couple pieces of L-shaped steel and welded them to the deck. They were all wonky and in a terrible state, so they've come off. I'm not going to replace in those. I don't know what they were. There's this water filling point. Well, that's completely in the way of what we're doing, so that needs to be removed. That little mark on the rail was just a little thing for a flag, so we'll replace that. And what we're going to do, well, I'm going to cut these old Sampson posts off because they're just grim. They're mild steel. They're just really rusty. Got layers of paint on them, so they're going. I've ordered stainless steel ones to replace those. We've made a bit more room here on the bow by moving this hatch back, so I think we've gained about 5 inches there. And then what I want to do is at least mark up and probably start to build some things here ready to bolt the windlass and everything down. I think to start with we'll mark it up, make sure everything looks right and in proportion and is sort of well laid out, and then proceed by making some things and getting some things installed up here. I want the windlass to be sort of here. We then need the anchor lock, and then this. Managed to pick this up secondhand. This, but I'm going to modify it heavily. I'm going to change the shape of it, move the wheel back, make it smaller really, because we don't need it to be that big. We just need something that can poke over the front just a little bit to clear the bow, but not lengthen the vessel too much. So we'll have that up here, and between that and the windlass I think we need to make a little stand for it to go on, a little sort of 3 or 4 inch wide bridge here, maybe 2 inches deep, because the chain will come off the top of the windlass and then over the roller, and I don't want that chain sort of flopping about too much. I want it to travel sort of quite close to a stainless steel rail. I don't want it to be hitting paintwork or resting on paintwork on this mild steel, because if it goes through the paint then it just causes rust. So we want to design something in such a way that the chain comes off the gypsy and it only contacts with stainless steel. There's no way it can touch this deck and cause corrosion. So yeah, we'll get the windlass template out and just start measuring up, I think, and see what we come up with. So this is the template that came with the Lewmar windlass. This is the chain lock. Now these These are access hatches to access the chain locker from up here. It's possible, if there's room in the chain locker, we could also store rope, mooring rope in them, because I don't really want, you know, wet rope inside the boat. It can't just be left out here because it'll all go mouldy. So could do with somewhere to be stored. What I might do is make a box that is one box with a divider, one for chain, one for rope, and has like a misting system, so I can pump some of the, you know, the RO water through the misting system to spray all over the anchor and the ropes to wash them off, so that they're stored, you know, clean, and you know that water can drain into the bilge collector and then just be pumped to the grey water tank. So yeah, I think probably at least one of these hatches, maybe both, maybe one on either side. But where we remove steel to put this in, it obviously weakens the deck, so we need to think about that and make sure there's enough strength left in the deck to cater for the winch. But I don't think it'd be a problem. I mean, this is 5mm steel. The winch instructions say that the deck should be 1 inch, but that's based on timber or fiberglass, not steel. I think 5mm steel is probably more than enough. And this sort of bridge we're going to build down here for this to sit upon, that's going to massively increase the strength of this deck, at least in the direction of all the forces upon that winch. It's going to be wanting to be pulled forwards, so if we have a bridge along there, sort of standing up 2 or 3 inches, maybe 3 or 4 inches wide, that will massively strengthen that section of the deck. And then if we cut these out, then we can just put some more supports along the edge inside for these, and maybe a couple extra bracing pieces across. But yeah, I think that'd be a pretty nice setup. It's just a question of making it look right, really. You know, I don't want it taking up the whole deck. I mean, I want it taking up as little as possible, but I don't want it all to look cramped. So I'll probably just fiddle about with this a bit until I'm happy with it, and then we'll start to draw up. So I printed off a couple of pictures I found online of these windlass systems. This is kind of like what we're aiming for. So we've got the bow roller here that sits over the bow, drops the chain down. This is dropping it some distance off of here. I know this is how they're supposed to be, but I don't really want that much clearance because it's going to increase the length of the boat by a foot or so if we do that. So I want to keep this to an absolute minimum. There's the windlass. There's no chain lock on this one. There is this cleat there, which is connected to this snubbing line, and we're going to do this. This is how you take the stress off the windlass once you're at anchor, and we do that in addition to putting the chain in the lock there. This one doesn't have a lock, so he's using these, but we'll do both, because then, you know, the chain doesn't snatch as the boat's sort of moving against it. There's this rubber damper here in the rope, and that absorbs the forces, so the boat doesn't sort of clunk on the anchor chain. We could put a post behind this. We have a spare post. I mean, I guess really I don't want these ropes going over the edge because it will rub the paint off the edge. Any paint that rubs off of this thing is going to cause rust, of course, because it's steel, whereas most boats are fiberglass. So we want to think about this and avoid anywhere where this rope is going to pass over the edge and rub paint off. Really, that rope I would want going down over the roller and then down the chain there. So we can think about that to make that possible, and that would probably mean we need to put that spare Sampson post behind the windlass, and think about the height so that we can, you know, connect the snubbing line around that without it rubbing on the windlass, taking the chrome off the windlass. So we'll have a little think about that once we've got everything laid up. So that was one idea. There's another one. Now this one has got the windlass, and almost immediately after, as close to it as it can possibly be placed, is the chain lock. Immediately after the windlass, and then it goes to a swivel and then the anchor, which is pulled up over the bow. So that is how we intend for our anchor to come up over the bow and then just sort of sit in the roller, poking over the end of the boat. I don't know if I want it that sort of cramped though. That's all very cramped, isn't it? It's like the most minimum amount of distance, but then maybe this person doesn't have very much room there to put it. So he's got the windlass immediately after the lock. There's just enough room then for the swivel and straight onto the anchor. There's no space there at all. That couldn't be any more compact. I don't think I want it that compact because it just looks all sort of squashed in. I'd like it to look good. And then what was this? I think this is that same picture again, but a close-up of the lock coming straight out of his windlass, which is here, straight into the lock. And there's another one. This one's a bit more sort of spaced out. So we've got the windlass, a few inches, chain lock, you know, a foot of chain, and then that's connected to the anchor, which is pulled up over the side of the bow rather than going sort of directly over the bow. There's a holster on the side. Well, that's an interesting way of doing it, because that doesn't make the vessel any longer, does it, if the anchor comes up over the side of the bow? Hadn't really thought about that, but I kind of like it to all be symmetrical, but definitely that's not a bad idea. Maybe he's got one either side I can't see on this. So depending on tides or winds, you might put it over one side or the other. I don't know. Might look into that a bit further. So yeah, there's another one. And immediately in front of this windlass, he's got the access to the chain locker. Those two access hatches, one either side. That I've seen that quite a lot, but I'm not sure about this design, because depending on where that chain lies, you might not be able to open them. I'd rather be able to open them no matter what's going on, whether the anchor is paid out or in or whatever. I want to be able to access that locker. So we'll be fitting ours in a way that they can be opened no matter what's going on. They'll be completely on their own. So we're just inside the bow now. I thought I'd have a measure up between the deck supports to see where we're going to be drilling through to make our lives easier, really, because I don't want to be cutting through a lot of these supports and then having to weld in new supports. And when I look at the shape and size inside this bow, you can see that probably the first 3 feet of that is not very much use as far as V-berth's concerned. It's just too sort of pointed and pitched at that end. So I think the V-berth could perhaps go as far as this support, and then everything in front of that is the chain locker and rope locker. That'll give us plenty of room for that as well. Now these, I have measured these, and they are, sorry, they are just under 30 centimetres apart. Now the hatches are 29.5 aperture size. So if I cut this nicely, those hatches will actually fit between these ones. So that's 59 and 90. Without taking these out, and then the windlass can go right in the middle of them. So everything then is, you know, concentric to one another, and we don't have to cut either of those supports out, which would be magic. And the other thing that I needed to consider was the anchor drop. When it comes out the windlass, it needs to drop 12 inches straight before the anchor starts to pile up. So 12 inches from there, you know, it's here, and we've got a huge amount of space underneath that for that anchor to pile up. It will never reach this level, so we will always maintain 12 inches of clearance below the horse. So that should be good. I'll need to think about how this is divided to a rope and chain locker later, but I think importantly that's exactly where we need to put this. We need to get these access hatches through this and get the windlass straight through the middle of there. So let's go and measure that up. So we've had a little mark up here, and what we've got, you can only just see these. That's where the locker hatches are going. The windlass in the middle, it's a 3-inch hole for the chain. I've just put a sort of hatched area there at the front just to mark the position of the bridge we're going to make there. So that's 7 centimetres wide, which is the same width as those, but it needs to be a bit wider, 9 or 10 centimetres wide, I think, down there. We just put these things into position, roughly, just to see where they go. So about there. That can represent the winch. Move this over here. That'll be a bit further forward, but that's pretty much how it's going to sit, and I think that looks pretty good. That's all pretty nicely spaced. There's 4 or 5 centimetres down there between the edge of the windlass either side, so you can get a sponge down there or clean. There's not going to be any little areas where algae or dirt collects there. There's again about, you know, it's about 10 centimetres there. Yeah, I think that looks pretty good. Back on the boat, first time this week. I don't have a lot of time today, but I'm going to try and get this water fitting out and then measure up to make this bridge, which will go between the windlass and this bump strip. Work out all the sizes and angles for the 5mm sheet I'm going to need to cut to produce that. And then maybe cut these out and fit these hatches, but we'll just see how much time we've got. Okay, hopefully you can see what I'm doing here. I'm going to measure this angle, and the reason for this is that the bridge that we're going to build at the front of the bow to level the chain and the chain lock and the bow roller up, it's going to have sides and a back and a front on it, and I want those to be angled at the same angle as this, so that it looks consistent, because this angle is matched with the wheelhouse and then it's matched on some panels on the side of the boat as well. So we're just going to measure this angle so that we can copy that angle when we weld the sides onto the bridge piece. So I'm going to use this little gauge to do it. So that's saying 0. If we come up here, that's 90 degrees. So let's just hold that against there. Okay, that's saying 70 degrees. So yeah, we're going to copy that. We'll have those sides and front and back at 70 degrees to the deck. So we're indoors now. So I needed to work out where at what position above the surface of the deck the chain comes out of the windlass. Interestingly enough, there's no mention of it in the manual for this windlass. So I've got to work it out myself. So I'm going to get a couple of pieces of metal just to stand this up on. And I've just tucked this, so when we put the galvanised anchor on, I've got 1 metre of this A4 stainless chain. This is going to go above the deck, so that all of the galvanised anchor will be down in the chain locker, but on the deck will be stainless, just so that it's completely wear resistant. We don't get any deterioration of the galvanised chain just sitting outside. So I'm using just this metre. So I've peeled back the cellophane on this and fed the chain down in there. It sits in quite nice, and it was paying out freely a minute ago. So we just now need to stand this up on a couple of pieces of steel so that cable can exit between them, and then measure the midpoint of this chain so we know exactly how high this bridge at the front needs to be. We'll measure the middle of this chain from the surface. This ruler starts at about 3 mil, so we'll add that in. So that is 123 mil plus 4 mil. So 127 mil. And this is the chain lock. So I just wanted to put some chain in it and see where the chain sits in relation to the base of the chain lock, so we can mount this in the correct position as well. So if we just feed this chain back in so it sits nicely in there. That sits flat on the inside surface of that. The chain is actually touching it, this lock. I don't even think the slot is as wide as the chain. The chain is 25 mil. It is made for 8 mil chain, so it's the right lock, but it's yeah, it's right down on top of that. So yeah, we will bear in mind that there's no play between the chain and the base of that, and install that in the correct position. So now we've worked out what the total width of this bridge will be, taking into consideration the 70-degree slopes all around it. I've drawn this onto the bow. You can see there the angled corners where the slopes would be at the front. And I've drawn this in such a position that there's 30 mil around the corners of that for cleaning the deck and sort of defouling. And at the back, again another 30 mil between, well, it's 30 mil between the beginning of the windlass, approximately, maybe slightly more because it sits inside that line. And that's what it will look like. I think that's quite nice. And interestingly, knowing that that's going to be 110 centimeters high, if we just simulate this height with these blocks in the approximate position that the surface is going to sit, which is there. Now, if we put this roller on as it is, So these blocks are only going to be about 10 centimetres, and it's actually another centimetre on top of that. But we can see that that almost clears the bow. We're not going to have to modify this very much at all. We're going to have to move this wheel. We're going to have to move this up so that it's in line with everything else. But position's quite nice. We'll cut this out so that clears that. And that will mean that we have to do very minimal modification to that, really, which is good because that's hard metal and I don't really want to mess up the polish on it. So that's actually sort of worked in our favour building that bridge. So I've worked out all the sizes of the bits of steel now. I think basically need to get cutting steel. Okay, so the sun's back and we're back on the deck. I cut this bridge that I marked up the other day, and so I've just assembled it up here to see what it looks like. Yeah, I mean, that's what we've got. So that will massively strengthen the deck in that position just in front of the windlass. And then what I'm also going to do is run 2 lengths of this inch heavy wall thickness steel along the sides, so that the whole of this, you know, windlass and bridge piece of the deck is, you know, strengthened a lot better. Because we are cutting these pieces out of the deck for these access hatches, I don't really see any way of avoiding this. I'm not having rope indoors, there's nowhere else to store it, and I don't want to have to be going into the chain locker from inside because that's going to be behind the V-berth. So we want the access from up here, and this is just the way that it's going to have to be. So yeah, we'll weaken the deck by cutting those out, but then we're strengthening it hugely by putting this here and these on the inside underneath. Inside of that are some 3 vertical supports. I'm going to cut a channel in the deck underneath it so that I can access to spray it with, you know, like spray tar on the inside. It's probably all I'm going to be able to get into there. And that will also cut out that water filling point. And then this roller, I've just sat it there, so it's sat on the front at the moment, but that will be slightly further forwards. We'll experiment with it once we've got this in its final position. And then we'll modify the bottom so it doesn't conflict with the deck. We'll move that roller up so that then everything is in line and that chain is coming off the top of the windlass, staying level all the way until it goes over the roller and over the bow. So yeah, I think we're ready to start cutting. So we're going to start cutting with this section at the front. I'm going to cut a rectangle around here, which will get rid of this. And what we're trying to achieve here is to give us access from underneath to spray the cavities of this bridge. So we've got these 3 spaces. Now, just sort of as it happens, the position of the top plate I've drawn on there, and each window is approximately the size of a spray can if I position them like that. So that's what we're going to do. Then I can just poke my hand up in here with a spray can, spray around. I will spray the inside before we weld it down, so all of the upper part is already sprayed. So it'll just be a question of getting into the weld at the bottom with the spray can from underneath. So that's what we'll do. We'll cut a channel down the middle, and then that won't matter that that's cut out because it's all going to be supported by these additional rods down the side. This stitching the 2 sides together and keeping them apart, and then the outer welded all the way around here. This is 5mm steel, so it's going to be even stronger with this on than it was with that piece in the middle. So let's get cutting. Okay, so I've cut around all these apertures we need to remove. Just going to try and get them out with the pry bar then we'll tidy up the corners with a die grinder. Right, so this is what we've done so far. It's looking pretty good. There's not too much rust around these, it's just layers and layers and layers of paint and a bit of surface rust, mostly mill scale underneath them. You can see how thick the paint was there where we had that rust around those fender baskets. Just layers and layers and layers and layers of paint. They're really thick. Probably a dozen or more coats of paint there. So yeah, I mean, we'll have to deal with all this rust and filling and maybe some patching later when we get to that, but for now we're just dealing with fitting what we're working on. So I think the next stage is to work on this windlass, and then we get some fur tan on it and cover it up tomorrow. Now then, Sean of Saving Blue Steel. Sean, I've been watching your videos for ages. You've saved me so much time making the mistakes before I made them. Thank you for that. In your last video, which I watched last night, I saw that you were having problems with the hole under the windlass. I think it's called a horse. And the hole was not big enough for the chain to go through it should the chain twist and jam sideways like this. So I'd drawn this on the deck ready to cut. Now the instructions for this Lewmar windlass say this needs to be 3 inches across, but the gasket that's supplied with it has a slot rather than a 3-inch hole. So I was thinking, well, I'll just cut a slot just like that. But then I wondered, after seeing your video, whether the slot is too tight to get that chain through sideways, which might explain why they've asked you to drill a 3-inch hole under it, even though the gasket has a slot, because of course the gasket's pliable. If it goes sideways, it can still pull through the gasket. So let's have a little look. So the slot in the Lewmar gasket, 38mm. How long is a piece of chain? 39mm. So yeah, there's a possibility that if that went through sideways, it could jam in there. Yeah, indeed, it does touch the sides. So I don't know about a 3-inch hole, but I mean, we're going to make it wider than the gasket, that's for sure, because that could theoretically jam in the hole if we don't make it bigger than that. So thank you for that, very helpful. We've got a new tool to try now. I was looking for mains powered needle guns, and they're not that easy to come by. There were some with very big motors on them, Chinese stuff. Didn't really like the look of that. I wanted something a bit more, you know, a bit more sort of slimline to sort of get into tight areas with it. And then I thought, well, I wonder if you can get an SDS one, and I managed to find one. That is an SDS needle gun. Surprisingly expensive for what it was. That was 35 quid. To me, that looks like a 10 quid item, but that was 35 quid. But that'll work with a normal SDS drill, which of course is nice and slim. So without this, I can get it into narrow areas. So let's take this off, fit that, turn that to hammer only, no rotary, or that'll spin around. Yeah. And we're going to give it a go on these areas of rust here. These were where I said there was some L-shaped, just sort of 3 or 4 inch long L-shaped, L-section steel coming up and pointing inwards. All I can think it was to hook some kind of mooring loop or something on, but they were very rusty. They've seriously pitted into the deck here. So what I'd like to do is get rid of this paint and rust, just treat these for now, and then when I come to welding up here, maybe we can just fill this in with some spot welds and get the level back up, so that we're putting the strength back into the deck. And we can see that the deck has even deformed around these areas, so there's obviously a bit of force and stress in this area, and this pitting has had an effect on the strength. So yeah, let's see if this works. I've got high hopes for this. So that tool actually works incredibly well. Didn't take many minutes at all, but it's removed all of the rubbish from all of these pits and there, and I ran around the bow with it as well. I can see a couple of little holes in the weld as well, which I can also fill in when we get the welder going up here. Wouldn't have noticed those if I hadn't have done that. Yeah, remarkable tool. Actually really good. Very fine needles on it. I would have expected them to be a bit thicker, but they did the job. They haven't sort of rounded off. Yeah, really happy with that. The only needle gun I found with a inline body was about 750 quid. So spending 35 quid on that tool, I'm really happy with that. Saves having to accommodate a much bigger tool in the workshop too. So what we're going to do with this, I'm just going to treat this this pitting with some Furtan so that we kill any rust that's left in there. And tomorrow we'll prime that. And then I think we need to get welding. To start the welding here on the bow, I just wanted to show you what we have come up with here. So for the additional supports, we've added 1, 2, 3, 4 1-inch pieces of box section steel. This is quite thick internal wall, 3mm or so. We're going to weld this inside, and then we had to remove this deck support, which is shaped. It's got a curve on it. We had to remove that because it conflicted with the holes for the deck hatches, the access hatches. So that needs to be moved back 1 centimetre. So remove that. We cut a hole in it for these supports to go straight through. So these have been set so that they're underneath the edge of this, bridge that we're building there. So the bridge, the deck, these will be sort of almost one continuous piece supporting this area where the windlass is going to go. And then to further support the windlass, I decided to fully enlarge that to the Lewmar windlass recommended a 3-inch ID hole underneath that flange with the slot in it. And I was going to cut a slot, but the more I thought about it, if the anchor chain was sort of coming from the side of a pyramid of chain underneath it, it wouldn't necessarily come up straight through the slot. So I thought, no, the best thing was just to stick to the guide, stick to 3-inch, and I found this piece of 316 stainless steel pipe, and I've cut that out so that can be welded in there flush with the deck. So that's that's the horse pipe, and that will further support that piece of deck in itself. So with all of these supports all around and that welded in there, I think that'll be a good strong mounting point for that windlass. So let's get welding. Right, I've been getting on with the welding on the bow. Some of the worst welding I've ever done. The whole thing was covered in this black tar. It's just impossible to get it all off, so it's just an absolute mess. I'm not even going to show you it, but it's strong enough. The bridge for the chain roller we're now just completing. I've tack welded inside of it. Now I'm just going to finish these welds down the sides, and I think I probably need to just grind these to get them to fit properly on the ends. Right, let's get on with it. Right, so we've been around and tidied up the welds on this. They're pretty good. There's a few low spots, but that'll be tidied up with high mil primer or filler when we come to this. But for now, that's fine for us to sort of weld on and then finish with a quick spray with primer. I've just positioned this bow roller on it. I'm just going to follow the profile of the bow roller, hang over the edge at that point, and we'll modify this so it clears that later on. But for now, I now need to just drill these holes through it, weld the nuts on the inside, then we can weld this down. We welded the box up. I've tack welded some bolts on the inside that correspond to the bow roller on the top. I've just put a bit of paint in those holes along the top, just to seal the holes really, but it dripped, so I sprayed the top. Now what we need to do is weld this on all the way around. Just kind of profile around the weld, tidy it up. All of this bare metal I've already washed back, so we're going to put some grey primer on this when we finish up, including the bridge. And then we're going to fit these hatches, possibly the windlass, possibly the bow roller, Otherwise I'm going to have to cover those to stop water getting in the holes, but there's not going to be much getting in there. Yeah, so let's get on with the welding. So we welded around that, and I've just been around with a flat wheel and a grinder, just tidying up the high spots in the weld. Not particularly bothered about the weld. We're going to go over that with a bead of filler to put a nice sort of smooth profile around it, just like we are with the gas bottle box surround. So yeah, this is now ready for priming. So maybe in a couple of videos time we'll come back to this and finish modifying that bow roller. I forgot to put the chain lock on, which is a pain, but I'll tap some holes in there for that. Oh, I have that in my pocket. Let's just pop that down there. There. Yeah. So the bow's looking altogether more ship shape now. We got the last of those awkward little bolts fitted in those hatches. I've got the bolts in the bottom of the windlass. Just loosely screwed the bow roller on because the hex screws are 7mm. I don't have a 7mm hex. I forgot to drill the holes for the chain lock, so I'll just drill out and thread the actual bridge there so you can screw directly into the bridge. But yeah, really happy with that. That's taken me a long time to do that, 2 weeks. So today's Friday. I normally upload a video tonight, but I'm just going to have to put this video together tonight and upload it tomorrow, but at least that's one a week anyway. Thank you for watching. See you in the next video.